All right, fellows, one last lesson for the week. But boy, is it very, very important. I hope that you haven't crammed all of these lessons in one day, as I warned you not to do, because this is a very, 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 very important one to pay attention to. And that is, we've already discussed using subqueries to join data together. And that's a good one, but it's it's one of those. Again, what I'm teaching you here is tools in your toolbox. If you're really going to use SQL and use it at a job, it's important to know that this works, how they work, because you never know when it could come in handy. However, whenever you refer to people that join tables together to get data, what they usually use is the join operator, not necessarily a subquery. And that's what we're going to go over here. So let's consider a different question. And that is, I want to know for my retail orders what items were, which items comprised each of these orders. But I also want the store and the store zip together too, so I know this store has X amount of items. It was sold in this year, that sort of thing. Well, let's begin by answering the questions. Well, let's narrow it down a bit and just say I want to know which items were ordered in which year. So, where does the data come from? Okay. So the order year comes from retail order. And let's see, which items, unfortunately, is not in retail order. It's an order item. So that is the SKU in order item. Now, you may ask yourself, well, SKU is also in order data too. Why am I not using that? Well, that's because in order to join this data together in step 3, I have to look at where these tables join together, like we did with SKU data and order item joined together on SKU. Well, retail order and SKU data do not directly join together, but retail order and order item do, and I can get SKU from this. So you want to take the fewest steps possible in a join to get to where you need to go. So that's why when I asked the question, I went to order item as opposed to SKU data. So that's where these are the two tables that my data comes from. And what data do I want to get back? Well, I said I wanted the year and I wanted the list of items. So let's see. The year is retail order year. And the other one is the list of items, order item.sku. And where do those tables join together? And that's in the relationships list. And they join together on order number. And again, order number is a foreign key in order item. It exists to create this relationship specifically for this reason. If order number were not here, not only would we not know which order these items belong to, but there would be no way to relate retail order to anything else in our database. It literally becomes a table almost without meaning. So that field was pulled into order item to give order item meaning and to relate it to retail order. So these tables join together on retail order dot order number spelling, and order item dot order number. So we had discussed when we're using a subquery, you can only return the data from the top level table. Well, we can't use a subquery to get this because we're literally asking for data back from both of those tables. In a subquery, I can only get data back from one of them. So I can't do that for a subquery. Now, the join operator works differently, and I'll demonstrate. And what I'm going to start with is, let me close all this mess. No saving. Query design, close. Now, just for simplicity's sake, we're going to start building this one little step at a time. And we're going to make it easy by doing select star. Now, I do know specifically what I'm after, but I'm going to demonstrate a problem here by doing select star. And then, like the typical SQL select from where framework, we need to list where the data comes from, select what fields from what tables. Well, now we've got two tables. And fortunately in Access, you can list multiple tables the way you select multiple fields. You just list them and put a comma to separate. So retail order, and comma, and then order item. Now this is a join. It's going to pull in the data from both of those tables. Now there is a critical piece of information missing here, but I left it out so that I can demonstrate what happens if you do this. I'm going to go ahead and run this. This is a valid query. I'll run it. Now, you may notice this is a lot of information, but it does list everything in both tables. We've got the store number and zip and order month and year and the total, and then we've got everything listed in order item. But there's a problem. And that problem is that every single thing is cross-listed with every other single thing in the table. Like literally, this order has ordered the same thing 4 times in 3 of these records. And you'll notice each of these retail order listings are listed once for each item in order item. And the reason that's happened is because we didn't tell the query where the tables join together. And when we do that, the database engine will cross-list every single possibility of those 2 sets of data together. I don't know why it does this. I would rather it failed. I assume there's some business reason why this does this. But in any case, if you make a join and you run it and you get back just a huge smattering of data that doesn't make any sense, chances are you've forgotten to tell it where the data joins together. So, what we do is in our SQL view, what we do is where we're going to use this to filter the information. Now in SQL Server this is done differently, and I'm going to cover that briefly, although it's not needed for this chapter of the book. And we've already determined that these tables join together on retail order, order number, and order item, order number. So what I want are the records where those are the same. And it'll run the query where it cross-lists everything and then only show me the ones where the order numbers match. That's where the table really joins together. So let's see. Run it. And here are the items. Here are the retail orders and the items that were ordered. So we're getting there. Now we're getting the right amount of records. Now, in SQL Server, this is done differently. And I'll go ahead and cover that here. the query in this case would be select star from retail order join order item on retail order number equals order item order number. SQL, if you're not working with SQL Server, you can check out for a little bit. This may come in handy for you though. SQL Server, when you perform a join, allows you to specify it more explicitly. You are joining this table to this table on these fields, and I actually prefer this sort of listing rather than the way Access does it, because whenever you see it listed this way, you know exactly what's happening. From this table, join to this one on these fields. Putting the where join part, listing where the fields join together in the where clause actually complicates things on the Access side of things, because you can also specify other conditions here. And order number equals 1000, for example. And now you've got part of your join conditions thrown in with your other field limiting conditions, and it just kind of complicates things. So if you're used to using SQL Server, this is the syntax for performing a join. All right, everyone. If you checked out, time to check back in. So I run this. It looks like it's joined my data together appropriately, because every time it's order number 1000 over here, it's 1000 over here, and so on. So now remember, what I asked for is I want to know how many items were sold in a year. So let's see. I want retail order dot order year and order item dot SKU. That's where those fields come from, because that's the data I said I wanted to get back. Now note, I said that in a subquery this wouldn't be possible, because whenever you use a subquery, the top level query isn't aware of what you pulled in the subquery. But in using join, data from all of the joined tables is available. And the data is joined together in the where clause. So let's run this. Okay, so 2010, these 4 things were ordered, and in 2011, these 4 things were ordered. We're getting there. So if I wanted to count how many things were sold in each year, I just do count. I run it, and it's going to fail because I'm asking for individual data next to an aggregate function. So now I have to group it. Retail order dot order year. So now I know in 2010 4 things were ordered, and in 2011 4 things were ordered. Now I will have a note about this table.field thing, and the fact that it's not necessary when there's only one, when that data only exists in one source here. And I'll explain what I mean by that. SKU is not in retail order. It's only in order item. So when I tell the query I want SKU, Access is smart enough to figure out, oh, he means order item, because it doesn't exist in retail order. But if you're talking about a field that exists in both, you must specify the table. Otherwise, Access won't know which order number you're talking about. So that's just a small aside. I'll do one more example. I want to know how much money each of my buyers has made. So I can take a look at this and say, let's see, one more quick example, and we'll answer the 3 questions. How much money has my buyers made? So SKU data, that's where my buyers are. And how much money have they made? Let's see, that is, it's either in retail order or order item, because we've got money made in both. Order total and extended price here. So, and retail order or order item. Now, if we wanted to know which to join specifically, some of you may have already intuitively thought of this. The correct answer is order item. And the reason is because SKU data to retail order, there is no direct relationship. But between SKU data and order item, there is. So it's always better to join, make the simplest join you can to get the data you need. So we're going to pull from SKU data and order item, because order item has our price, SKU data has our buyer, and it's a simple one first level relationship join. So in my notes, I'm going to take out this retail order and just say comes from SKU data and order item. So what data do I want to get back? Well, I want SKU data dot buyer and order item dot extended price. And where do those tables join together? Well, you can have a look at the relationship again if you want to be sure. You can also do this through the table design if you wanted to do it kind of in a more meticulous manner. You know, there's SKU here, there's SKU there. But we can look at it here and go, well, that joins on SKU. So SKU data dot SKU and order item dot SKU. And because we're trying to get data from both tables, we can't use a subquery. So this is what we'll do. We'll build a new query and select. Select is what fields we wanted to get back. So from here, that's the data from step 2. From which tables? That's from step 1. And instead of the and, I'm just going to put a comma to separate them, because Access won't recognize the and. And where tells it where it needs to be told. Anytime you do a join, you have to tell the DBMS where the tables join together, or you're going to get a cross listing of everything. So that's step 3. Where do those tables join together? Instead of and, equals. Where the SKU data SKU is equal to the order item SKU. That's where they join. Let's run it. Hey, look at that. It tells me basically how much money each of my buyers has made. And if I want to total it up and group it, I can do that too. Just like we did in the last one. If I want to know, if I want to group all my Nancy Meyers up and sum them up, I can do that. Sum up the extended price. Group by buyer. So now I have taken the data of these items belong to these people, and these items have been ordered for X amount of times for this total amount. I have taken that data and turned it into meaningful information that means something to a manager. And from this, I can tell I really want to keep Cindy Lowe around. She's selling stuff. And so this is meaningful information. This means something to a business. And joins are incredibly, incredibly powerful if you learn how to use them correctly. So, as with last week, please feel free to ask me questions, give me feedback and input, and we'll be going over this together in our in-class exercise. Have a good week.